Okay, so let's finish off this section here. So let's do a couple more u substitutions. Let's do u equals 6x, that's the inside angle. So du is 6 dx. So I know I can carry along the integral sign, it's cosecant of u, and then dx here is going to get replaced with du over 6. So that's the same thing as saying 1/6 times du. So I pull that 1/6 outside, and then think about what the antiderivative of cosecant squared is. So that's negative cotangent of u plus the c. And so then put the x's back in. Okay. So here it's very similar to this one, correct? So let's see if we can see the pattern. So this is the same thing as saying 1/4 times x, right? X over 4. So du is 1/4 dx. So that gives me 4 du is dx, because I know I'm going to need to substitute in for dx. So cosecant squared of u, and then I have a 4 du. So let's pull that 4 on the outside. And so then I get a negative 4 cotangent of u plus c. So the negative 4 cotangent of x over 4. So let's just even contrast these two. So here I had the angle 6x, and I got a 1/6 out in the front, right? And then the negatives comes from the antiderivative of cosecant squared. Here I had an x over 4, and so here I have a 4 in the front, which is 1 over 1/4. So we're going to establish the pattern. So it also works for this, right? So let's just go ahead and do this one. Du is 5x, so that's 5 dx. So I know I'm going to get cosecant of u, cotangent of u, and we're wanting to replace the dx. So dx is going to get replaced with du over 5, which is the same thing as saying 1/5 on the outside of the integral. So now let's take the antiderivative. So I get a negative cosecant of u plus a c. So let's put the x's back in. All right, so I think we can establish, we got e's to do next, and then we're going to get a nice healthy pattern that we'll be able to use. All right, so we know this one. We know the antiderivative of e to the x is e to the x dx. But we don't know the antiderivative of e to the 3x. So I need to do an easy u substitution, letting u equal 3x. So I get 3 dx. So then, I want to solve for dx. So I get du over 3 is equal to dx. Let me erase that. Okay. All right, so now let's substitute in. So I get the integral of e to the u, and dx gets replaced with du over 3. Again, I'm always going to suggest that you just take a moment and clean it up so you see where the numbers are. You can pull them on the outside. Antiderivative of e to the u is e to the u. And so I get, putting the x's back in. All right, so remember, this is if I take the derivative of 1/3 e to the 3x plus c, I should get this answer e to the 3x, right? So is it equal to e to the 3x? I do believe it is, right? So let's check it. So I carry the 1/3 along. I take the derivative of e to the 3x. It's e to the 3x times 3, and the derivative of c is 0. Oh, look at that. The 3 and the 1/3 cancel, so I do get e to the 3x. Okay, so let's remember chain rule, and this is integration, so this is antiderivative. Chain rule is derivative, right? Chain rule is for the derivative. So that says that the derivative of e to the 3x is e to the 3x times 3. And so what did we get here for integral of e to the 3x? So we found that the integral of e to the 3x turned out to be 1/3 e to the 3x plus c. So there's quite a big difference, right? This is the derivative. This is the antiderivative. Okay, so let's do some harder ones here. Here I'm going to let u equal negative x. Du will give me negative dx. So I'm going to move that negative to the other side. So I get integral of e to the u. And I want to replace dx, so that's going to be a negative du. So negative on the outside, e to the u du. So that gives me negative, whoops. And I'm taking the antiderivative. So I get e to the u plus c. So negative e to the negative x plus c. All right, let's just finish off one more here. So if here I would let u equal x over 4. So du is, okay, just be careful. Make sure you know that that means 1/4 times x. So I get 1/4 dx, or 4 du is equal to dx. So I get e to the u, and dx gets replaced with 4 du. So I'd have 4 integral e to the u du. The integral of e to the u is e to the u, and then put the x's back in. All right, so you have to be careful. This u substitution is a tool that you cannot use every time. This u substitution will not work. This will not work for u substitution, and neither will this one. No u sub. We can't even do this integral. So you have to be careful that u substitution won't work all the time. I've given you some nice easy ones to look at. So let's look at these patterns in the next lecture.